This is Miss Farhana. Miss Farhana around? Oh, she's not around. Farhana, are you there? Okay. Probably lambat sikit. Never mind. Mr. Irfan. Calling for Irfan. Also not around.
Yeah, I
Okay.
think so.
Okay. It's okay. Later when probably when they during the break nanti I'll call them up if they have something to show or share with us. So let us start our session today. Let me just share my screen. Okay. You all see my screen?
Yes, sir.
Yes, doctor.
All right. Let's start. Thank you very much, everyone, for your attention and also your participation. Really appreciate it. So let's continue with our session today. We've already covered engine classifications and components last week under chapter 2, part 1, well, chapter 2.1. Basically, and we are still in chapter 2, which is covering engine components and cycles. We've done engine components last week, which is 2.1. But this week, we're going to move on to engine cycles, which is 2.2, which is still under the same chapter. But nevertheless, hopefully we can finish this chapter 2 this week, and we can move on to chapter 3 next week. So let us move on to engine cycles. So for today, for this session, we're covering four-stroke cycle. Under the four-stroke cycle, we will cover the spark ignition engine, or what we call as SI engine. We will also cover compression ignition engine, or what we call as CI engine. Now, SI engine and CI engine, in layman words, SI we call it as people call it as gasoline or petrol engine, or CI engine, and also CI engine they call it as diesel engine lah. Okay. But in engineering terms, we call them as SI engine and also CI. And then we're gonna cover a little bit on engine timing. Okay. And then once we're done with the four-stroke cycle, later we will go into two-stroke cycle. And then very briefly to touch on the differences between four-stroke and two-stroke, and also differences between SI and also CI. So those are the topics that we're gonna cover today. Yeah. So let's start on four-stroke cycle first. Okay. And then we're gonna cover on spark ignition engine, or SI engine, or what they call or probably most of you call known as gasoline or petrol engine. Right? So very briefly, just before we start, we need to know who actually created the four-stroke spark ignition engine, which is Nicholas Otto, died in 1891. He is known as the inventor of modern internal combustion engine. Hence, the cycle that was named after him, which is Otto cycle. So, in other words, briefly, in essence, basically, SI engine is basically the control of gases, which uses the valves, and also the components involved, which is cylinder head, cylinder block, piston, intake, and also exhaust valves, crankshafts, and connecting rods. So those are the main components, okay, which we already covered last week. Okay. So this is basically some layout. Of course, in internal combustion engine, in four-stroke cycle, there is four stroke, okay, which is started with an intake stroke, followed by compression stroke, okay. compression stroke, and then followed by power stroke, or sometimes they call it as expansion stroke. Okay, either power or expansion stroke, doesn't really matter, but most of the books are using the word power stroke. And then of course you have the exhaust stroke. So there you have 4 strokes, hence the 4-stroke cycle. I believe that most of you are quite have already familiar with this, probably in your previous subjects, also in previous courses and so forth. So for those who are already familiar with this, let's just recap this. Okay, so you will have first the intake stroke, okay, and then you have the compression stroke, okay, and then you have the third, which is the power stroke, and then you have the exhaust stroke. So that is basically the 4 strokes, okay. Please take note that power stroke can also be known as expansion stroke. So, but in this course, we will use power stroke, but it doesn't matter if you write it as expansion. Okay. Let us go through each of these stroke. The first one is the intake stroke. Okay. So this intake stroke draws in combustible mixture of fuel and air past the throttle body and into the intake valves into the cylinder, or in other words, into the combustion chamber. So in the case for port fuel injection, where the fuel is actually injected before the intake valve, the gas that goes into the combustion chamber is referred as a mixture of fuel and air. But in the case for GDI, or gasoline direct injection, the gas that enters the combustion chamber is purely air, because the fuel is actually the fuel is actually injected directly into the combustion chamber. Okay, so it depends. But nevertheless, the intake stroke is whereby the fresh air that comes from the air intake system goes into the combustion chamber. Okay, this is whereby the intake valves opens to allow the gas enter the combustion chamber, and the movement of the piston is from TDC, which is the top dead center, TDC, and the piston moves from TDC to BDC downwards. Okay, bottom dead center. TDC refers to the maximum position, highest position of the piston, and BDC refers to the lowest position of the piston. Okay, so that action of piston from TDC to BDC, the volume inside the combustion chamber expands. Okay, so when the expansion of the volume happens, that actually creates a vacuum to a vacuum or a void to draw in fresh air into the combustion chamber. So by the time the piston reaches the BDC, by right, all the volume on top of the piston and also in the combustion chamber is filled with the air. Okay, so that movement from the movement of the piston from TDC to BDC is a reciprocating motion. But in the case for the crankshaft, it rotates. Okay, and for the piston to move from TDC to BDC, the crankshaft rotates at 180 degrees. Okay, so that is basically your intake stroke. Next, following to the intake stroke, then you have the compression stroke. So right immediately after the piston reaches BDC, the piston starts to move from BDC back to EDC. Okay, so during this compression stroke, with all the air and also the mixture that has filled up the volume, when the piston moves from BDC to EDC, it compresses the mixture. Okay, the compression stroke is when the valves needs to be closed. Okay, because otherwise you won't have the you won't have the compression, which raises which raises both the pressure and also the temperature of the mixture. So in other words, it raises the pressure. Okay, when the pressure starts to increase, the density of the air also increases, and hence, when the density of the air increases, the temperature also increases. Okay, a spark ignites the mixture towards the end of the compression stroke. So, as the piston reaches towards the TDC, and this is when the pressure inside the combustion chamber is at its peak, a spark is triggered. Okay, and this is when the combustion starts to happen. So during this case, both valves needs to be closed lah, because otherwise you won't have that compression effect. And of course, the movement of the piston from BDC to the TDC, the crank rotation is 180 degrees. Okay, also 180 degrees. Okay, so that is basically compression stroke. And then followed by that, you have the power stroke or expansion stroke. So this is basically when the combustion starts to happen. Okay, an explosion happens. The combustion gas expands. When the combustion gas expands due to the combustion and also explosion, it creates a force to push the piston downwards, okay, back to BDC. So, expansion stroke, or better known as power stroke, results of a combustion of the fuel air mixture, okay. And during this case, and during this stroke also, both valves remain closed. Okay, so as the gas expand, it pushes, or it creates a force pushing the piston downwards. So the piston moves from TDC to the BDC with a crank rotation of 180 degrees. So that is the power stroke. So based on the first stroke, based on the inset stroke, compression stroke, and also power stroke, this is the only stroke that actually produces power. Okay, because this is when the gas expands, it creates a force pushing the piston downwards to the BDC, and the force is actually being transferred. Okay, transferred to the crankshaft to rotate. Okay, and hence, of course, the power is basically translated from the crankshaft to the flywheel to the transmission to the drive shaft and also the wheels for your vehicles to move lah, and also in other words and so forth. Bear in mind that the power that is created inside the combustion chamber is what we call as indicated power. Indicated power. Okay, whereas the power that is being produced at the flywheel is what we call as brake power. Brake power. So usually when you refer to books or catalogs and so forth, they will also always declare the brake power, which is the power at the flywheel. Okay? But what about the power at your wheels? Okay, the power that is being produced at the wheel. This is what they call, we refer as wheel power. Okay, so there's a difference between indicator power, brake power, and of course wheel power. Depends on which one you would like to refer. So that is basically the power stroke. Then the last stroke, which is of course the penutup, which is the exhaust stroke. So the exhaust stroke, immediately after the power is being generated, the piston reaches the BDC, the piston needs to move back up the TDC. This is when the piston starts to push all the burn gases out in the combustion chamber outside through the exhaust valve. Okay, and because the movement of the piston from BDC to the TDC, the exhaust gas is being expelled out. Okay, the exhaust stroke pushes out the burn gases past the exhaust valve. Okay, of course, the exhaust valve needs to be open lah, because otherwise it cannot go in, it cannot exceed the combustion chamber. And again, because the movement of the piston from BDC to TDC, we know definitely the crank rotation must be 180 degrees. So far you have 4 strokes to complete. And with the 4 stroke, then only you have is equivalent to 1 cycle. Okay. So don't be confused between 4 stroke and 1 cycle. It's totally different. Okay. So let's just summarize the 4 stroke. So the intake stroke draws the combustible mixture of fuel and air past the throttle body and intake valve into the cylinder, or in other words, into the combustion chamber. This is the first stroke. And the second stroke, which is the compression stroke, the valves are closed and the piston moves from BDC to TDC. It raises the pressure and also temperature. And of course, towards the end of the movement of the piston, close to TDC, a spark is being ignited and it triggers the combustion. Okay. And then you have the expansion stroke. A combustion happens, and then the gas expands, and it pushes the piston downwards, or better known as the power stroke, as a result of the combustion. And then you, of course, lastly you have the exhaust stroke, where the piston moves back up from BDC to TDC to push or to expel all the gases that has been burned and already combust outside through the exhaust valve. Okay, so there you go. You have 4 strokes easily to remember. Once you understand it, you will remember it forever. Okay, 4 stroke cycle. So just go through. Let's just go through this video. Take a few seconds just to see just to recap the 4 stroke cycle. Okay, I hope you all can understand that movement over there. But of course, you can always refer to a better videos in YouTube's and so forth just to get a better idea. Or probably in YouTube's, I think they have lots of uh, very good quality videos for you to better understand the 4 stroke cycle. Now, let me ask you, how many degrees rotation is needed for 1 stroke to complete? Anyone? Anyone? Yeah. 1 stroke is 180, not 550, 540. So remember, 1 stroke is always, this is 1 stroke, this is 1 stroke, this is 1 stroke, this is 1 stroke. So 1 stroke is always 180 degrees. Okay, clear?
Yes, doctor.
Okay. I just want to make sure that you understand. But then, okay, remember the crank rotation. Okay, remember the crank rotation. Then comes the question, how many degrees rotation for 1 cycle to complete? If you say 1 stroke is 180 degrees, then 1 cycle is how many degrees?
720 degrees.
Yeah, okay, thank you. So, that's just a question just to make sure that you totally understand, what's the difference between 180, 720, what's the difference between 1 stroke, what's the difference between 4 stroke, what's the difference between 1 cycle, and so forth. Because later when you do your test and also exam, these are some of the phrases that will be used. So in order to make sure that you totally understand the situation of the question, I just want to make sure that you are very clear on this one. So among the problems of spark ignition engine, okay, when the initial pressure is too high, the compressed gases ahead of the flame will auto ignite, causing a problem called knock, or sometimes we call it as pre-ignition. or sometimes we call it as detonation. Okay. In other words, when you have this during the compression stroke, when the piston starts to move, when the piston moves from BDC to the TDC, it raises up the pressure and also raises up the temperature. Okay. In spark ignition engine, you want the combustion starts to happen at a very specific time. We don't want it to be too early. Okay. Now, because the fact that we want it to have the ignition at a specific time, which is why we control when does the spark plug starts to trigger. Okay, but then because the fact that the engine in actual life is very hot. Okay, it's very hot, and when the piston starts to compress the air, so as the piston starts to move up halfway, the pressure and also the temperature is so high that it triggers the combustion by itself without the spark plug assistance. So because the fact that when the combustion starts earlier, okay, and usually most of the time the piston hasn't reached the TDC yet. Okay. So what happens if you have a combustion happens before the piston reaches the TDC, and the combustion starts to happen during the movement of when the piston is on the way to the TDC. So this is what the phenomena, what they call as, or even they call as pre-ignition or knocking or detonation. Okay. In the as we go on with other chapters in this course, we will touch on during the combustion in the combustion chapter. We will definitely cover more on knocking and ignition and detonation. So now you know that the the worst enemy for spark ignition engine is always knocking or pre-ignition or detonation. Without this problem, spark ignition engines can actually perform better. And due to the fact that this problem happens, okay, there are so many limitations, and because of these limitations, of course, there's so many technologies that is being introduced in engines nowadays, which is what is the mitigation to prevent knocking from happen. Okay, one of the things that I can highlight now is, for example, intercooler. Okay, intercooler is basically the purpose of intercooler in turbocharged engines. Basically, they need to cool down the air intake. Okay, why they need to cool down air intake? Because the fact that they don't want the pressure, the temperature during the compression stroke. Okay, during the compression stroke raises too high. Because why? If it's too high, it will create knocking or detonation and pre-ignition. So intercooler is just one. Okay, the other one is, sorry, I'm lost in the slides. Okay, so that is basically intercooler is one of the technologies that is being introduced to prevent knocking from happen or pre-ignition or detonation. Measures or mitigation manufacturers are trying to do to prevent knocking or pre-ignition and detonation from happening is by having a higher RON fuel. Okay, so with higher RON fuel, of course, the fuel itself is pretty much has a higher octane number. In other words, it's hard for the fuel to obtain. We will cover more on fuel RON later in our later chapter, so don't worry on that. So again, the worst enemy for spark ignition engine is always knocking pre-ignition and so. So that is pretty much on spark ignition engine. Any questions so far? Okay, good. No questions so far. Let's.
Doctor,
Yes.
I would like to ask a question about RON again. RONs, the octane
Yeah.
numbers.
Yeah.
So is the current like the currently the lowest RON that we can get in Malaysia is 95, right? Correct me if I'm wrong.
Yes.
Okay, is it high enough for our cars yang with normal combustion ratio? Our everyday cars are like the Pro Duas and the Protons.
Okay. The
Or
it actually dep-
should we like
yes.
spend more for RON 97?
It actually depends on the vehicle itself. Okay. Some cars are actually developed purposely to meet RON 97. Some cars are purposely developed for RON 95. So on the older days, or old cars, so it means they develop cars according to the availability of the RON in their market, in their market of where the vehicle will be selling to the market lah. Depends lah. But like for instance, like certain cars are actually like okay, let's take one car lah. Let's take Proton lah for example. Just for example, they know that they are selling cars only in Malaysia. For example, they know if they know that they are only selling cars for Malaysia market only, then definitely they need to be aware that the fuel RON in Malaysia there's only RON 95 and RON 97. Okay, so definitely if they know that the availability of the RON is only 95 and 97, they definitely need to develop cars or develop engines that should be able to meet RON 95. Okay, why do I say that? Because if you have an engine that is supposed to run on 95, it should be no problem, should be by right theoretically for it to run on RON 97. But if the vehicle is actually purposely developed for for a higher RON 97, for example, then it will be an issue for the vehicle to run at a lower RON 95, for example. So if the car, like I think some cars from the Japanese, they are purposely developed for RON 97 and above. So when they came to Malaysia, for example, some of these cars, they can't actually run on RON 95 because the engine and also the engine management system, they are all calibrated and developed for only for RON 97. So it depends on the vehicle actually. Does that answer your question, Daniel?
Yes, okay. Sebab
Doktor,
Yes, sure.
macam mana nak tahu macam enjin kita tu dia experience knocking? Basically macam dah ada bunyi ke kena buka enjin tu ke?
Okay. Most of the time knocking ni cannot be heard, but severe knocking is very audible lah. It's very clear. Okay, kalau I nak cerita bab knocking ni 2-3 hari 3 malam tak habis. But knocking, if you drive for modern cars nowadays, knocking still happens. Knocking still happens, okay? But you cannot hear it. That is one thing. Second, the engine management system or the ECU is clever enough to detect if there's any knocking, then what the EMS or engine management system will do is they will try to retard your ignition timing. So I will definitely I will explain that in the later chapters. We will cover on the ignition timing, the combustion punya chapter on that. But definitely knocking ni can be classified as severe or not severe. So most of the time, sometimes it's very severe. When it's severe, the engine management system is clever enough to retard your initial timing. But otherwise, if it's a very mild or very not very harmful knocking, then the engine would allow it. But this not harmful knocking, usually you cannot hear. It's very, I would say, very minimum. But it's likely to happen in our daily driving. Especially if you drive Mitsubishi cars, especially if you drive Mitsubishi cars, knocking is very apparent. If you drive the Mitsubishi Lancer and so forth, you can see if you're running on high loads, you can hear a slight knocking, very slight knocking. And of course, the impact of knocking from severe knocking, it can lead to engine damage. Combustion starts to your engine starts to overheat. It will lead to very catastrophe damage lah to your engine. So yes, knocking does happen on daily basis.
Bunyi dia macam kereta diesel ke tak?
Knocking ni, it sounds like macam you goreng keropok. Saya ni tak pandai nak mimik nak bunyi knocking tu. But okay, kalau you bunyi dia, it's exactly bunyi when bila you goreng, bila you panaskan minyak panas tu dia menggelegak kan. That bunyi menggelegak tu is basically is like knocking.
Oh, okay.
But of course you can try to YouTube lah. But that's how I subjectively dengar bunyi knocking tu. Kalau I would like to describe, it's like macam bunyi minyak dalam kuali yang panas. Well, of course, nanti I can yeah, if you have if you have time nanti, definitely I will show you some videos of probably some bunyi like recordings if I have anything dalam my file on knocking. Okay.
Okay, Doctor.
So okay, can we move on to next topic, which is compression ignition engine, or CI engine, or diesel engine. So a little bit on compression ignition engine. Of course, developed by Mr. Rudolf Diesel, died in 1913. Also known as compression ignition engine, or some of us know this as diesel engine. Okay, the diesel engine operates at high compression ratio, very high compared to SI engine. Okay, now kenapa why SI engine we cannot have a very high compression ratio? Again, because of knocking. But in diesel, we don't have that issue. Okay, so diesel engines operate at high compression ratios, resulting in high theoretical efficiency compared to spark ignition engine. So in other words, in terms of thermal efficiency, CI engine is much way better than compared to SI engine. Okay? It's again, it's based on the 4-stroke. It's exactly the same, but with a minor differences. Let's go through each of the stroke again. Under the CI engine, again under the intake stroke, it's the same thing. Exhaust, the intake valves opens, the pistons moves from TDC to BDC. It draws air, the volume expands, it draws air into the cylinder or combustion chamber. Now, and all CI engine, you have the fuel injector directly in the combustion chamber. Okay, all diesels have the fuel injector inside the combustion chamber. Unlike SI engine, under the SI engine, if there's a possibility that under the PFI, port fuel injection, you have the fuel injector before the intake valves. But for the GDI, of course, you have the fuel injector inside the combustion chamber. But for diesel engine or CI engine, all injectors fuel injectors are actually inside the combustion chamber. Okay. Again, other features is also is always the same. Piston moves from TDC to BDC in the intake stroke. Inlet valves open, draws in air, volume expands, the crank rotates at 180. Yeah. So that is the intake stroke. Next, it's the same is the compression stroke. This is when the piston starts to move from BDC to the TDC. It raises the air temperature above the auto ignition temperature of the fuel. Okay, so the diesel fuel is sprayed into the cylinder near the end of the compression stroke. Okay, just before the piston reaches the TDC. Evaporation, mixing, ignition, and combustion of the diesel fuel during the later stage of the compression stroke and the first part of the power stroke. Both valves and exhaust valves during this stroke is closed. Pistons moves from BDC to the TDC. Now, if you look at diesel fuel is sprayed into the okay. The air is actually is being compressed above the auto ignition temperature of the fuel. So in other words, this is why CI engine has a much higher compression ratio. It relies on the compression, okay, to increase the pressure, okay, and because the pressure is so high, it auto ignites by itself, okay, because of the diesel characteristics, okay. So in other words, it doesn't have any spark plugs if you notice, because it relies on the fuel self ignition temperature. Okay. Okay, but later we will cover on the fuel diesel in the later chapter. So in this, you understand what is actually self ignition temperature, what are the characteristics such as RON, MON, and so forth. Okay, but for now we will treat the diesel fuel has its own auto ignition temperature to self trigger itself. Okay, self trigger itself because of the high pressure and temperature. Okay. Again, this for diesel engine, there's no spark plugs. Okay. So that's basically another tips lah for you, just in case you want to look out for you to actually detect whether the engine is a SI engine or CI engine. It's basically if there's a spark plug, definitely it's a SI. Sorry. If there's no spark plug, definitely it's a CI or diesel. Okay. But don't be confused. Don't be confused because diesel engines or CI engines, they have glow plugs. Glow plugs and spark plug is totally different. Okay, we will cover that later. Glow plugs is supposed to heat the air that goes inside, that passes through the intake manifold, that goes into the combustion chamber. Glow plug supposed to increase the air intake temperature. It doesn't serve the purpose to start the combustion or triggers the combustion. Okay, so don't be confused. Physically, if you open up, if you open up a diesel vehicle, don't be confused between spark plugs and glow plugs. Glow plugs is usually located on the intake side, whereas spark plugs is usually located in the cylinder head. So don't be confused between glow plugs. And then you have the power stroke. Again, it's the same thing as the SI engine. Combustion starts to happen. The gas expands, better known as the power stroke. Okay. During the stroke, both intake and exhaust valves needs to be closed because otherwise, there will be some leakings. Then it the combustion would be efficient. Piston starts to travel from TDC down to BDC. Crank rotation again, same thing, 180 degrees. This is the power stroke. And this is when the power starts to being transferred from the force that is acting on the piston to the conrod, to the crankshaft, to the flywheel, to your gearbox or transmission, to your drive shaft, and lastly to your wheels. Okay. Lastly, last stroke, which is exhaust stroke, same thing. Okay, as SI engine, piston moves from BDC to TDC, pushes out all the burn gases through the exhaust valve. Exhaust valves, of course, needs to be open, okay, because otherwise the gas cannot go anywhere. Piston moves from BDC to TDC, BDC to TDC, yes, and the crank rotation is 180 degrees. So the only difference between the CI and SI and also CI, between the SI and also CI, is basically, I'm just highlighting the main ones. First, there's no spark plug. Second, it relies on self-ignition temperature. Uh, and of course, the rest of the features in CI is more like the same as SI, apart from different fuels being used. Of course, in SI you're using gasoline, ethanol, like gasoline-based fuel, whereas on CI engine you're using diesel fuel. Okay, just to summarize on the CI engine or diesel engine, intake stroke draws inlet air past the intake valves into the cylinder, same thing as the SI engine. Compression stroke raises the air temperature above the auto ignition temperature of the fuel, which is the diesel. This is totally different compared to the SI. Diesel fuel is sprayed into the cylinder near the end of the compression stroke. Okay. Evaporation, mixing, ignition, and combustion of the diesel fuel during the later stage of the compression and the first part of the power stroke. So it's in between the compression and also power stroke. And you have the exhaust stroke that pushes out the burn gases past the exhaust stroke. This is exactly the same as the SI engine as well. So let's talk about the main problems, or among the main problems of CI engine. Diesel engine performance is limited by the formation of smoke, which is why lorries and commercial vehicles if you notice, produce lots of black smokes, which forms if there's an inadequate mixing of the fuel and air. So in other words, yes, the smoke that is being produced by the diesel combustion is not very pleasant. Okay. So there you have the CI engine. Okay. Any questions so far before we go for a 10 minutes break?
Untuk compression ignition Dr. diesel engine kan,
Yeah.
why does it, I mean, it has more torque and everything kan, but why is it like emit more emissions? Is it because of the
Okay.
fuel or?
Yep. Yes, because in SI engine, if you want to have more power, tunggu sekejap main kat luar lah. Go. Tutup. Sorry about that. For SI engine, basically, if you want to produce more power, okay, if you want to produce more power, more torque, the only way to do it is by having more air goes into the cylinder for the combustion. Okay, when more air goes into the cylinder, okay, then you put sufficient amount of fuel to cater on how much air that goes into the cylinder. Okay, so the fuel follows how much air is being uh, put into the cylinder. That is SI engine. Okay, so in order to produce more power in SI engine, all you need to worry about is how much air you can fill into the combustion chamber. That's the basic rule. Okay, so now you know how to produce more power from SI engine. But on CI engine, it's a different case. Okay, CI engine depends because the fact that it it is more dependable on the fuel rather than the air, and because it relies on the self-ignition temperature. Okay, and due to that, based on that fact, your combustion is being manipulated of how much fuel you are putting inside the combustion chamber or cylinder. So in diesel or CI engine, it's simple as more fuel, more power. But not in the case for SI engine. SI engine, you need more air, then you have fuel needs to be correct, then you get power. But on CI engine, no. CI engine is more fuel, more power. And more power, more fuel, what happens? Lots of smoke. Is that okay? Then I try to put it in like.
Yeah. Understand.
Any more questions before we go for a 10 minutes break? Okay, kalau tak ada, we shall meet back in 10 minutes. And now is it's 8:03. So we'll meet we'll start at 9:05, okay?
Alright, Doctor.
All right, see you back in 9:05.
Kan, Doktor?
All right, okay, move on. Since okay, since you all are already familiar or get some idea on the four-stroke cycle, spark ignition cycle, and also the spark ignition engine and also compression engines. Remember that during the four-stroke cycles, at certain strokes, the valve intake and also exhaust valve opens and closes at accordingly.
Doctor, you
Doctor?
mute yourself.
Allah, sorry. Okay, sorry about that. You didn't hear me throughout the explanation just now.
Yes,
Yes.
Doctor.
Okay.
Yeah. Until we saw you open the laser pointer, then we realized that.
Oh, okay, all right. Sorry. Okay, basically what you have. Thank you for writing. So under this engine timing is very important for you to understand, which is why you need to have a very clear understanding on this, because you will use this later in your solving problems or solving questions later in the later chapters. Okay. So what is engine timing? Is basically it connects your it times the movement. The time engine timing refers to the timing of where is the location of your piston and also your valve opening. Okay. So under the engine timing, so in other words, your valve train is actually being driven by the crankshaft. Okay, crankshaft, and it is connected using a timing chain or a timing belt. Okay. So so camshaft pulley is actually connected to the your camshaft, and your camshaft pushes your intake valve or exhaust valve to open or close and so forth. So the timing of the valve train is actually connected to the crankshaft. Okay. So those three are the main components under the engine timing, which is crankshaft pulley, timing belt or timing chain in certain engines, and also crankshaft pulley. So to complete a 4-stroke cycle, okay, okay, crankshafts rotate 720 degrees. This is basically what you answered just now. But to complete a 4-stroke cycle, or in other words, to complete one complete cycle, okay, what is the rotational degree for the camshaft pulley? Anyone? Take a guess.
Again, Doctor?
For a 4-stroke cycle, okay, so to complete 4-stroke, you need 720 degrees. But in other words, your crank pulley rotates 720 degrees for the 4-stroke. But for camshaft pulley, how many degrees? If crank pulley rotates 720, camshaft pulley rotates how many degrees?
180.
360 off.
Yeah, it's always half. It's half. It's always 360. Okay. So whenever, in order for you, if you turn your crankshaft twice, complete rotation, your crankshaft pulley will only turn once. It's half of the rotation lah. Okay. So, but then how, if all, in order for us to really put this timing, valve events, piston position, crank rotation into a description, it will be using what they call as engine timing diagram. Okay, so engine timing diagram always refer to your crank rotation. Okay, don't be mistaken of the rotation of the cam pulley, because cam pulley is only half. So don't worry so much on the camshaft pulley, because it doesn't really matter, because your reference is always crankshaft rotation. Okay, so whenever I say that the crank rotates at 70 degrees, that refers to the crank rotation 70 degrees lah. And if I say that the piston moves from BDC to TDC at a crank rotation of 70 degrees, now you know that the crank rotates 70 degrees, but you don't know where does the piston punya position is at, which later is part of the course for you to calculate where is the position of the piston and so forth. So don't worry on that, that will be covered in later chapters. But the main point of this diagram is to show that how can we describe the engine timing diagram. The timing of the engine is basically by using what they call as engine timing diagram. So this is one of the example over here. So you can see in the engine timing diagram, it tells you where does the intake valves open, whereas where does the intake valves closes, and where does the exhaust valve open, and when does the exhaust valve closes, with respect to the piston position based on crank rotation. I will explain that in the following slide. So, but you can see that at 12 o'clock over here, this is when your piston is at TDC. We always read this engine timing diagram in clockwise direction. Okay. Let's move on to the next slide. I will explain you further on this. So under the intake and exhaust valve timing diagram, let's look at this diagram on the right first. Okay. To complete, we know that to complete 4-stroke cycle or one complete cycle is 720 degrees. Okay. We will start definitely on the intake stroke. Okay. So we will start with top dead center first. Okay. Refer to the cursor that can you see my cursor?
Yes, doctor.
Yes, doctor.
Okay, so start with the intake stroke. We know that the intake stroke, the piston moves from TDC to BDC. So as the pistons move from TDC to BDC, so it rotates 180 degrees. By the time the cursor reaches here, we know that the piston is at bottom dead center BDC, and then after that is compression stroke. So the piston starts to move back up to TDC. So another 180 degrees. So you have the compression stroke, and then you have the power stroke. Okay, and we're talking about piston position first. Okay, so don't leave out the valves first. We're talking about the piston position first. So pistons is at TDC, moving to BDC on the power stroke. It moves down 180 degrees to BDC, and then followed by exhaust stroke, move back up 180 degrees where it reaches the back to TDC. Hence, you have two complete circles or two complete revolutions, which is 720 degrees. Now you know the piston position, but how you want to include the events of intake valve opening and exhaust intake valve closes, exhaust valve opening, and also intake valve closes with respect to the piston position. So normally during the intake stroke, okay, the intake valve is open, starts to open before the piston reaches BDC, which is why you can see that the intake valve opens 12 degrees before TDC. Does that make sense? Because it opens earlier. Does it make sense?
Yes, doctor.
Okay. So, but I will try to make things the word more more as easy as possible for you to understand. So intake valve open, we don't we usually call it as IVO. Exhaust valve open, we call it EVO, EVC. Intake valve closes, we call as IVC. Exhaust valve opens, we call it as EVO. So IVO is 12 degrees. It opens. It starts to open 12 degrees before the piston reaches TDC. And during this intake stroke, we know that the intake valve actually always open up until it reaches over here. So intake valves always close. It's normal. It's normal. It's always closed after the piston reaches the BDC and goes into compression stroke, which is why intake valves is actually open 56 degrees after BDC. Okay, or in other words, 56 degrees ABDC. A stands for after, BDC stands for bottom dead center. So you can say that intake valves closes 56 degrees ABDC. And then when this intake valves closes, it goes compression stroke. And during this compression stroke, okay, after 56 degrees, this we know that both the intake and also exhaust valve are closed. So during compression stroke, so both valves close, and then you have the piston reaches the TDC and then goes for power stroke. And during the power stroke, exhaust valves also closes. But as it moves down over here, the exhaust valve starts to open. This is normal, okay, for any engine. The exhaust valve starts to open during the power stroke, towards the end of the power stroke, 47 degrees before BDC, or in other words, BBDC. Okay, and then the exhaust valve opens for exhaust stroke as it reaches piston reaches the TDC. the exhaust valve still doesn't closes, but instead it will close as soon as it goes into the intake stroke. So exhaust valve are slightly delayed to close 21 degrees after TDC. Or in other words, 21 degrees ATDC after top dead center. So those are some of the things of how you can read your timing diagram. But you can always read over here, which is being colored. So for your better understanding, blue is the intake valve, red is the exhaust valve. So you can see of how the relation of how you can record or describe your opening and closing of the intake and also exhaust valve with respect to the piston position and also crank rotation. But of course, this is a very static diagram. You can always go to some of the quite interesting quality videos in YouTube for better understanding. But I hope that you have a very basic understanding on this uh, for you to use in your later application in solving problems in later chapters lah. Okay. So, okay, are you okay with this?
Datuk, kenapa? I have a question, sorry.
Yes, okay.
Why the exhaust valve dengan intake valve tu dia ada overlap when it's one is opening, but then why macam let's say okay where intake valve opens, right? Why at that point not exhaust valve closes?
Okay, because they want to delay the exhaust valve to because exhaust gas eventually on normal internal combustion engine, exhaust gas for you to expel everything for you to expel all the combustible gas, you need a lot of time for the exhaust gas to basically to go out, to totally go out from the cylinder lah. Which is why the exhaust valve is slightly delayed lah. So this figure ni is might be not be probably not represent all engines, but this is just for your reference. But usually it's being delayed after TDC. But one of the reason why they get it overlap is because they want there's a reason why overlap. So it means when you say overlap is whereby both the intake and also exhaust valve are open.
Yes.
So during this valve overlap is what they call overlap. Main purpose of overlap is what they call as the purpose is what they known as scavenging and also internal EGR lah. Okay. So basically, when you have a valve overlap, you have the intake air that goes in at the same time, and also the exhaust valve, exhaust gases goes out to the through the exhaust valve at the same time lah. So when the whole of fresh air goes inside the combustion chamber, it will assist for the exhaust gas to expel out through the exhaust valve. So this is what they call as scavenging. So you know because because there's a very large difference of pressure between the in cylinder and also the outside cylinder. That's why the momentum of the exhaust gas has already started during the movement of the exhaust gas goes out through the exhaust valve has already started during the exhaust stroke. But in later, during the end of the exhaust stroke, intake valve starts to open. This will actually creates a scavenging effect to further assist the exhaust gas to go out through the exhaust valve. So scavenging is one thing, but there's another reason why they purposely use overlap for internal is what they call as internal EGR. So it depends on how it depends on the manipulation of when does the intake valve open and exhaust valve close. Different values create different effect of how the gases flow. But I definitely for two main reasons. One is scavenging, and the other one is internal EGR. Internal EGR is the opposite of scavenging. It traps certain portion of the exhaust gas inside the cylinder or combustion chamber. Why? Because they want to remain some of the unburned gases in the combustion chamber. So in other words, you don't have to put in more fuel because there's a lot of unburned mixture. You can still use, or in other words, you can still recycle the exhaust gas for the following combustion. So that is internal EGR. But it depends. You can actually manipulate the opening of the intake and also the close of the exhaust valve. Deep, which one do you want? Do you want it to be scavenging or do you want it to be EGR? Of course, different purposes has a different value and so. But you know, whatever the value over here, it doesn't represent anything. It's just a value for you to for me to give examples.
Then another one is like, that means on the top dead center, both of the valves are either closing and starting to open in this diagram lah. Kan? Does that mean like when the piston at the top of at the top dead center, that means the valve still opens, in which in the compression stroke means that there will be pressure or the air volume going out. It's like, faham tak doktor? Saya pun tak tahu nak explain macam ni.
Because okay, you're talking about the overlap, is it? You're still talking about the overlap.
Overlap, but then on the, sebab kenapa at the top dead center, valve tu still buka lagi. Dia tak fully close. Macam tu je. Sebab,
Which one? During the overlap? Are you talking about the overlap?
Yes. At the top dead center.
Of course, intake valves ni, if you can imagine lah, intake valves ni is all mechanical. It requires time for it to start to open until its maximum opening point. So it requires time lah. You're looking at probably 1 second or less than 1 second. But definitely, when you that is taken into consideration. So over here, when you see over here the dotted lines ni is it marks 12 degrees before TDC ni. It actually marks of when does the valve starts to open, but it doesn't tell you when is the maximum opening point.
Okay.
So different engines got different different delay time. This is what they call as valve opening delay time. So certain engines in racing engines usually it's very minimal, very minimal. You're looking at probably very milliseconds. So at high speed you can consider it's very instantaneous lah. But then we don't want to have that in normal engines or passenger cars because of the wear and tear is very high. So yes, the one that the timing diagram that I show over here is a simplified version. But of course, in a very advanced timing diagram, you have the maximum opening point of the valves and so forth.
And so that means in the piston itself, mestilah ada indent kan, so that it doesn't hit the exhaust, both the exhaust and intake valve.
Yes,
Case
correct.
that.
Yes, correct. Yeah, correct. Some engines well, engines with lower compression ratios usually they don't have that any issues. But they definitely that is part of the design consideration. They need to make sure that when the valve is actually at the maximum, when the valve is actually at the maximum opening point or MOP, what they call as MOP, and when the piston is really at TDC, it doesn't clashes. So those are one of the design challenges when they design engines.
Alright, okay. Thank you, Doctor.
Okay, so let's move on to the two-stroke cycle now. I think most of you I don't think any of you, probably little of you. Anyone riding a two-stroke motorcycle? Tak ada, semua orang bawa ni. Semua orang bawa ni. Wai suku lah. Tak ada orang bawa.
I think Zuhaimi, sir.
Zoemi, okay. Zoemi, where's Zoemi?
Saya sir.
What motorcycle are you riding? Two-stroke cycle? What motorcycle? Which
125
motorcycle?
ZR.
Not Aprilia, eh?
No. Aprilia is too expensive, sir.
Not yet.
Not yet.
Not yet, inshallah.
Inshallah.
Okay, so let's talk about two-stroke cycle. Okay, some of you are crazy about two-stroke cycle for certain reason. Okay, but because I think it's because of the speed lah, not because of the noise. Okay, nowadays you cannot have too loud exhaust. So be careful of two-stroke cycle. Can get summoned. So two-stroke cycle developed by Mr. Douglas Clark in 1878. It only needs one revolution to complete a cycle. So in four-stroke cycle, you need 2 revolutions or 720 degrees. But in two-stroke cycle, you only need 360 degrees to produce one power stroke. Which is why Zohemi punya motorcycle is much way better. Correct, Zohemi?
Yes, sir.
Dia bawa LC, sir.
Yasir, sir. He ride TZM. Sir.
Yes, is those days lah. RX, siapa ada 70,000 RX nowadays? Anyone?
Oh, Yasir.
You have? Okay. It is mechanically simpler and have higher power to weight ratio compared to four-stroke engine. Okay. Do you hear? Can you see that, Zoyemi?
Yes, sir.
Yeah. So it's much more simpler. Okay, Zohemi's motorcycle is much more simpler. Zohemi's motorcycle have higher power to weight ratio compared to your Waisuku. Okay. It pushes out exhaust by incoming air, is what we call as scavenging. So Zohemi, your motorcycle is always doing scavenging. Okay, pushing out the exhaust by scavenging. That is the only way it can expel all the burn gases outside the cylinder or combustion chamber. So scavenging is not perfect. Okay, nevertheless, Zoemi punya motorcycle is not always perfect because scavenging is not perfect and depend on port design and shape of the piston top. Okay, let's see some of the port designs and shape of the pistons. Okay, this is basically you can see where does the how does the movement of the piston over 360 degrees. So you can see of how the fuel and air is being goes into the block. It goes up as the piston goes up versus the air. Okay, there's a special channel that goes into the combustion chamber, and as the piston goes down, it goes through the exhaust port. So in other words, the piston itself act as the valves or what they call as ports. Okay, so there's no valves in this case. But nevertheless, this is just one example. There's a few types of ports. One is the cross scavenging. So this is where the air goes into the intake port and goes out through another port, what they call it exhaust ports. So there's no valves. The piston itself seals the port itself as the piston moves from PDC and also PDC. And another type of scavenging is what it calls as loop scavenging. This is where the exhaust and also the air intake ports are actually close together. So it is being sealed and being the movement of the air that goes inside the cylinder and also the expel of the burn gases is being controlled by the movement of the piston itself. This is what we call as loop scavenging. Another one, the famous one, which is the uniflow scavenging, where it uses the exhaust valve to expel the exhaust gases. This is pretty much quite very common. Is this the one you have in your motorcycle, Mr. Zohimi? Zohimi? Or you don't know?
I don't know, sir.
Okay, but now later you can find out whether your motorcycle is it a cross scavenging, a loop scavenging, or is it a uniflow scavenging? So uniflow scavenging, basically you have a single flow of air intake system that goes inside the combustion chamber, and of course you rely on the exhaust valve to expel the burn gas. It is the most efficient scavenging system, okay, but requires exhaust valve in the cylinder head. So for Mr. Zaimi, if you notice if you manage to identify your motorcycle other exhaust valve, then you have a uniflow scavenging two-stroke cycle. So very quick summary, nothing much on the two-stroke. We won't emphasize much on the two-stroke. It's just for us to understand what's the difference between two-stroke and also four-stroke. In a two-stroke cycle, during compression of the crankcase, a sub-atmospheric pressure is created in the crankcase. This opens a reed valve, letting air rush into the crankcase. So this is basically referring to the loop scavenging and also cross scavenging. Okay. So when piston reverse direction during combustion, expansion begins. And the crankcase closes the reed valves so that the air is compressed. As the piston travels further, it uncovers the exhaust port so the exhaust gas can leave the cylinder. The intake port opens and compressed air in the crankcase flows into the cylinder, pushing out the remaining gas. So that is basically just a summarize on the two-stroke cycle. Among the problems for a two-stroke cycle, yes, this is a very big problem for two-stroke. Some air will go straight into the cylinder and out the exhaust port. So in other words, it's not that efficient because of the wasted gases and also wasted air. Short circuiting always happens. Okay, so when short circuit happens, so it's not producing as much power as what it's supposed to. So some air will also mix with exhaust gases, and the remaining incoming air will out of portion of this mixture. Okay, some air will also mix with the exhaust gas. So because of the scavenging need, so you cannot control much of the scavenging unless the engine is actually properly designed in order for the scavenging to really happen in an efficient manner. Another problems associated with two-stroke cycle, yes, it produces much more power because of the 360 degrees revolution to produce one cycle or one power stroke, but because of that it is producing much more noise, and also it consumes more fuel and also produce more emission compared to four stroke cycle. So let's compare the difference between four stroke cycle and two stroke cycle. But just to take note, so some of this, okay, never mind. Just let's go through this one. What's the difference between four-stroke engine and also two-stroke engine? So thermodynamically, cycle is completed in four-stroke cycle of the piston in 2 revolutions, whereas on a two-stroke cycle, you only need 1 revolution to complete a complete cycle. Okay, so hence two-stroke cycle is more efficient. Okay. Because of the above, the four-stroke cycle turning moment is not so uniform, and hence a heavier flywheel is needed. Okay, and because just imagine on a four-stroke cycle, there's only one out of the 4 stroke, only one produces power, which is the power stroke. Hence, you need a balancer. Okay, and it's not balanced. Okay, so therefore you need a heavy flywheel to compensate with the ununiform rotation. Whereas on a two-stroke engine, because the fact that you only you only need one complete revolution, okay, to produce power. You don't need so much of very heavy flywheel for you to counter to balance the rotation. Okay, and because of one power stroke for two revolutions, power produced for same size of engine is less, and for the same power for the engine is heavier and bulkier, and therefore four-stroke cycle is much more bigger and also heavier compared to two-stroke engine usually very much lighter weight and also components compared to four-stroke. And of course, there's other also differences. I would read through some of the differences. You can read by yourself, but it's pretty much straightforward. Okay, let me tell you now. This is a common question in your test and also exam. Common question in your test and exam. Okay, I won't tell you many times. I will tell you now. This is a common question in your test and also exam. So hopefully, if the question in your test or in your exam, there's a question, list down 6 differences between four-stroke and two-stroke. There you go. This is your answers. So next is basically the differences between SI engine and also CI engine. We are approaching towards end of this lecture today. Again, there's differences between SI and also CI in many areas, such as in the areas of basic cycle, differences in terms of fuel, load, ignition, combustion ratio, speed, thermal efficiency, weight. Again, this is a very, very common question in your test and also exam. So do please study this. Definitely, it will will definitely being considered in your test and also your exam. Okay, so if the question asks you list down 7 differences between SI and also CI engine, there you go. This is all. Yeah, this should be the answer for those questions. Okay, that is basically ends up our
Doctor, you are muted again.
Doctor, no attendance for today?
hello.
Hello. Okay.
Am I muted?
No.
Okay, alright. Sorry.
Right. That's it. Lepas tu terus.
Okay. Okay, thank you.
Okay.
Do you have any questions?
No attendance for today,
So
Doctor?
far, no.
Sorry, can you speak louder? I cannot hear you.
Attendance.
Sorry, can you repeat the question back?
I want to say attendance. No attendance for today?
Yeah. Definitely. I will share you attendance just before we close. Okay. Definitely.
So I have a question, sir.
Yeah. Go on.
It's regarding about the auto ignite of petrol and petrol. Basically, what is the maximum pressure or temperature? What is the maximum pressure and temperature of a petrol fuel when auto ignite? That's a
Okay.
curious question I have.
Okay. Let me rephrase the question. What is the maximum pressure? Because it's two totally different things. It's either can I answer the maximum pressure first, then later I can answer you on the auto ignition pressure. Siapa tadi yang tanya?
Saya fine.
Sekejap. Give me 1 sec.
Oh, bye.
Oh, Okay, coming back to your question tadi tu, okay. Okay. Sorry, I was doing something. Maximum pressure basically depends on the engine itself. So certain engines are actually designed for very high operational maximum operational pressure. Okay, very high pressure, especially on turbocharged engines. They are actually designed to work on at a very maximum pressure during the so in other words, when you talk about pressure, this is the combustion pressure during during your combustion. So certain engines you're looking at between 90 bar to between some engines some engines for, like, if we say it's performance engines, they are actually designed to have a much way maximum pressure compared to small size engine cars. So it depends. So if you look at a 1.3 liter engine and 1.3 liter NA engine and a 1.3 liter turbocharged engine, definitely they are actually designed to work at a different pressure. Definitely on a 1.3 liter turbocharged engine, it has a higher working pressure compared to the natural aspirated engine. Does that answer your question, Fahim? Fahim, is it?
So around 90 bar.
Roughly about too. It depends. If you ask me what is the 1.6 liter turbocharged engine, you're looking at nominal value of between 70 to 90 bar.
So it very depends on the engine.
Yes.
There's no fixed value or something. I mean, I'm just asking, what is the pressure? Does basically a gasoline engine, not a gasoline engine, a gasoline fuel will auto ignite? This is a question I'm actually curious about.
Oh, okay, all right. Okay, the maximum pressure. It depends. It depends. Let's say that if you are running a 1.6 liter turbocharged engine, for example, and the combustion pressure is designed to operate at 90 bar, for example, the auto ignition temperature can actually triggers itself below 90 bar if the temperature is extremely high, or it can go above 90 bar with a lower temperature. So it does have some correlation between the pressure and temperature, but at what value, it's pretty much depending on the design of the engine itself. Some engines, I know that some engines, they have very good design that they tend to have very minimum auto ignition. Whereas some engines are very prone to have a very regular auto ignition. So yeah, it depends on the characteristics of the engine. Actually, it depends on the design of our design. So if you asking the value, there's no certain value to say what is the pressure that the auto ignition will happen.
Okay, I understand. So it depends on the pressure and also the temperature as well.
Yeah, it is a combination. But definitely, later when we will come to a later chapter in the combustion punya chapter. That is when nanti I will explain you of how the pressure and temperature will actually relates to the auto ignition, knocking, detonation, and so forth.
Okay, Rata. That's all.
Doctor.
Yep.
I'm currently referencing the slides on the last slide, SI engine versus CI engine.
Yep.
I read speed. Basically, SI engine is a high speed engine and CI engine is a low speed engine. That's why I think if you drive an SI, the RPM goes like 6,000, 7,000. Meanwhile, in diesel engine, they only go about 3 to 4,000, right? Um, it is stated here due to lightweight and also homogeneous combustion. But then I read somewhere else that because of um, the speed, the SI engine is high speed is also attributed because of the shorter stroke distance. Is it stroke distance or shorter stroke compared to CI? Because CI needs longer stroke because of the higher compression ratio. Is that true?
Yes, true. I mean, definitely, I think some of the points over here might be outdated a bit.
Okay.
With the latest trend of engine designs nowadays, they have like break the conventional tradition of how SI and also CI engine should be produced lah. So I think the latest sources, I haven't updated the latest sources, but of course, whatever you say tadi, yes, it's true.
Okay. So does this mean like in SI engine, those basically if we have a shorter stroke, we would have a higher speed, higher operational speed?
Yes, that's what Honda is doing on VTEC engines.
Oh, okay, I see.
And then that's how they got 11,000, 12,000 RPM on what?
But then, if the stroke is short, that means are there any effects on the torque or power?
Yeah. Yes, but because let's talk about Honda. I don't like Honda, but I'm really fascinated with the technologies. What you say is true. They compensated that, but because the fact that they have the VTEC technology to compensate, and they know that their VTEC system has a better advantage. They lose on certain parts of having a shorter stroke. Main purpose, they have a shorter stroke compared to other engines. If you're talking about the bore dengan stroke ratios, they have a much shorter stroke. They purposely have that because they wanted to have a higher RPM, but they compensate and they compensated the disadvantages of the shorter stroke, because shorter stroke definitely has a poor combustion, but they compensated that with a better air delivery with the VTEC system. So that's how they strategize the whole engine design. We know that you can never, on natural aspirated engine, you can never beat VTEC's technology. They can actually, you can have, if you talk about volumetric efficiency for natural aspirated engines, Honda is really good at it. They know what they're doing. They are very detailed and very precise on how the air is being delivered in conversation. Up to the extent of where, if you notice the density or the surface for Type R engines on the by the VTECs, they have a different surface roughness compared to the normal VTEC engines on under the Type R engines. So that's how they can actually that's how they strategize the whole overall engine design.
And then, but then, what is the disadvantages of having a shorter stroke? I mean, I guess like
The
low end torque or something.
yeah, definitely the low end torque. The combustion is not that if you compare for between if you relatively compare between a long stroke and a short stroke, a longer stroke would have a better combustion because of the compression of the mixture is much more better compared to a shorter stroke.
And lastly, since we are talking about Honda, um, Tadi Dr. said mentioned about Honda not back in the days not optimizing not optimizing their engines to run on RON 95, right? And I did a quick Google search. I realized that it started 2009 and upwards, then baru diorang optimize for RON 95. So my friend here, she drives a 2007 CRV, and because recently minyak naik and such and so, what is your advice? Should you since currently she's been filling up her tank with 97, but now kenalah 95 sebab student kan, so
Right. Okay.
is there any problems with that if the engine is not optimized for 95?
Okay.
let's
I
say?
dare not to answer that because kalau
Oh.
ada damage ke apa nanti dia claim kat I. But from my opinion, I'm not giving suggestion. From my opinion,
Okay, opinions, yes.
if I was in his shoe or her shoe, okay, I would definitely try. I will definitely try to fit in RON 95 and see if there's any, and
Okay.
drive it carefully.
Okay.
And so that means I don't really put high load on the engine and try out if there's any and observe if there's any difference in terms of the engine temperature, power delivery, and so forth. If there's anything that is obvious, temperature slightly goes up, engine temperature slightly goes up, and there's rough noise from the engine, so I would definitely go back to RON 97.
Okay.
This is how it works, Daniel. When engines, they are actually designed for RON 97. Engines, they don't know what's the fuel.
Mm-hmm. Yes.
They don't know what's the fuel. So they can only behave to the certain calibration or programming that the manufacturer has done. So in the case of whereby if the engine is calibrated for RON 97, so in the case of whereby you fill in RON 95, there's a possibility that knocking might happen. But in engine nowadays, they are quite clever enough to detect knocking. So if there's any knocking, the engine management system should be clever enough to do some changes in the ignition timing to prevent knocking and to basically to mitigate the knock events lah. But their actions are limited. If there's a slight knocking, definitely it can be prevented lah by the management system. But if the knocking is very severe, so like I say, the EMS is only the actions that the EMS can do is very limited. So it will try its best to prevent the knocking by retarding the ignition timing. But if the knocking is very very severe, then it will definitely it won't go away. So this is a problem. So and when that happens, definitely, of course, it will damage your engine lah. If you're talking about, it will definitely damage your engine. So those are the things, and that is the worst case that I can tell you lah.
Sebab I
But-
think yep.
But yeah, I've done it before previously with in fact, actually, I had some experience where some of the vehicles that I tested before were supposed to run on 97, but we just tested on RON 95. Yes, knocking does happen, but because of the fact that we are only drivers, we cannot actually monitor what is going on in the engine unless you have special equipment and so forth. So the only way for you to observe is basically you can look at your engine temperatures, if there's any rough noise. Those are some of the indications saying that no, it's not like RON 95 is not good. Please go back to RON 97. So what we did was actually we drained back the RON 95, fill up back RON 97. But there's a risk for during the tryout too that it might damage your engine. But it's just if you're willing to take that risk and willing discreetly try out the car, then it should be no problem.
Mhm. Because after this class I will tomorrow tomorrow I will dia ajak keluar and then maybe I can
Tengok wayang.
experiment tak
Okay.
eksperimen lah kalau ada knocking tu then I cakap akan dia.
Yeah. But usually knocking only happens when your engine load is at 50% and above.
Engine load 50%, that means is it because of the weight that it carries or
Yeah,
the speed
yeah,
of
it's
the
knocking always happens at below 4,000 when your load is high.
oh okay I see.
Below 4,000, load is high. Contohnya, if you have a manual car, okay, you can try whether your car is knocking it down. You can try when your car is at stop position or idling. You can shift into gear 5 and press the throttle, release the clutch on the 5th gear or the 4th gear. So if there's any minyak masak, bunyi minyak masak menggelegak tu, then that's knocking lah.
Alright, okay.
So usually most of the time knocking tends to happen at lower speed with high load.
Yang tu nanti boleh try dekat kereta assistant advisor saya sebab dia bawa Wira manual tak saya.
Yeah. But on automatic, it's hard to try out.
Yeah. So in automatic kena ada load as in like berat kereta tu fully loaded and then baru boleh dapat rasa. I see.
Yeah.
Okay. Oh, and also Irfan just texted me and he said that rumah dia blackout tadi lepas maghrib and battery phone dia habis. So tak sempat nak bagi
Never
tahu.
mind. Okay. And things happen. So no worries. So let me just choose for next week punya session. Fahim, next week. Boleh Fahim?
Sure, sir.
Just a quick one, the news. Okay, is that okay, Fahim?
Any news regarding ICE, sir?
Yes.
Okay.
Fahim. Mr. Amir Ali. Mr. Amir, are you there?
Yes, doctor.
Yes, next week. Can you share something on the news? Just a very quick one next week.
Okay.
All right. And Mr. James. Mr. James, are you there? Mr. James?
Yes, sir.
Are you in KL? Are you in Johor, James? Or
Yeah.
abroad? So are you okay next week? Okay, is that okay?
Yeah, okay.
Just a very quick, article or news related to internal combustion engine. Doesn't really matter whether it's positive or negative. Doesn't really matter. Just to share. Okay.
Okay.
Mr. Zulkarnain, are you there?
Yes, doctor.
Is that okay next week, Zul?
Okay.
And Miss Elizabeth, are you there? Elizabeth,
Okay, sir.
are you in Johor or abroad?
No, at home.
In Sabah, is it?
Sarawak.
Sarawak, right. I thought I saw you a few months ago.
Wrong person.
Wrong person. Okay.
No.
Okay. So 5 of you. Let's hear any
Also,
news.
Doctor,
Sorry?
Yeah, Irfan would say Irfan asked that he wants to present his part yang today yang dia miss ni next week juga.
Okay.
Okay.
All right. Great.
So
I'll
6
catch up
people.
with the the one siapa tadi? Irfan.
Farhan now.
Farhana. So I'll catch up with Farhana. Nanti you catch up with Farhana balik.
Boleh.
Very quick one. No need to elaborate. Just to share the news sahaja. Okay. So thank you very much, everyone. It's a good session. Just before we finish this one, please do click in your attendance. I put that link in the chat box over there. Other than that, thank you very much. Thank you for your attention and thank you for your participation. I hope to see you all next week, same day, same time. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you,
Thank
Roger.
you, sir.
Okay, thank you, sir.